Hey, we have another integral today here on the board. We have the integral of dx over x squared plus x plus 1 all squared. And I know in the past I did the integral of just x squared plus x plus 1, but we've got this square in here that's just going to make it a little bit more involved. So what I want to do for my first step is I'm going to rewrite this, but I'm going to complete the square on this denominator. There is a 1 coefficient on this x. What I'll do is take half of that and write the denominator as x plus 1/2 squared. And if you square this out, you'll get x squared plus x plus a fourth. Well, we've got a 1 there, so what I'm going to do is add 3/4 on there so that we're not changing it, and then this whole thing is going to be squared. And then I can just take this 3/4 and rewrite it as square root of 3 over 2 squared. So this is, and with the integral in this form here, what I'm going to do is a trig substitution now. So I'm going to call, and because we're adding here, for x plus 1/2, I'm going to substitute with tan of t. But I want to use this value in front, so we're going to say x plus 1/2, and I'm going to substitute for square root of 3 over 2 tan t. Just noticing that when that's squared, we end up with 3/4 tan squared t. And I want a value for the derivative of this thing, so taking the derivative of the left side, we're just going to have dx, and then the derivative of this is going to be square root of 3 over 2. Derivative of tangent is going to be secant squared t dt. And I'll just go ahead and make the substitution. So we'll plug in our dx value in the numerator. So we're going to square root of 3 over 2 secant squared. And then in the denominator, we're going to have here, we'll have 3/4 tan squared t. And this thing I'm going to put back as 3/4. I probably could have just left it that way, and this whole thing's squared. And then I just want to factor a 3/4 out from here, and we'll square that and bring it outside of the integral. So if I square 3/4, it's going to be 9 over 16, but we'll take the reciprocal. So I'm going to bring out front 16 over 9. And I'm also going to bring out this square root of 3 over 2. And then I'll keep my numerator of secant squared t. And I'm running out of space, but... And then from here, let's just recognize the identity. Tan squared t plus 1 is the same thing. This thing is the same thing as secant squared t, but it's squared. So in the denominator, we're going to have secant to the 4th t. And then I'll just cancel a 2 and a 16 here for an 8. So let's rewrite this. We're going to have 8 over square root of 3 over 9. And then for the integral here, I'm going to cancel 2 of these with 2 of these. So we have secant squared in the denominator. Well, that's the same thing as cosine squared of t. But then I'll use power reduction for cosine here. So we can write cosine squared of t as 1/2 plus 1/2 cosine of 2t dt. And then I'm just going to integrate this thing. So integrating 1/2, we're going to have 1/2 t, and then integrating, bringing the 2 out, we'll have a 1/4, and then this is going to be just sine 2t. Next, for sine of 2t, I'm just going to use the identity that sine of 2t, this is the same thing as 2 sine t cosine t, and that'll get us all back to just a single t for our angle. So let's put that back in here. But then I'll cancel the 2 with the 4 here, and we'll have a 1/2. So factoring out the 1/2, that's just going to give me in front 4 square root of 3 over 9, and then we're just going to have t sine t cos t. Then all I need to do now is just kind of get a value for t, sine t, and cos t, and that's not going to be too hard. So I'm going to go back to what we have over here. Now if I solve for tan of t, I can multiply by 2 square root of 3 on both sides here. So tan of t is going to be the same thing as 2 square root of 3 x plus 1/2. So distributing that in, I can write my tan t as 2x plus 1 over square root of 3. Or I could take the inverse on here, and we can say that t is the same thing as tan inverse 2x plus 1 over square root of 3. So that's going to give us our value of t right here. But what about sine t and cosine t? Well, for these two values, I'm just going to draw my triangle, my right triangle, knowing that we have a value for tan of t right here. So if we make this angle t, tan t is opposite over adjacent. So our opposite side we can write as 2x plus 1, and we can write our adjacent as square root of 3. And then if we use the Pythagorean theorem to find the hypotenuse, we find that it's going to be 4x squared plus 4x plus 4. And of course we could factor a 4 out of this, but I think I'm just going to leave it for now. So then this is going to allow me to get a value for sine and cosine. So our sine t is going to be just opposite over hypotenuse, so we can write sine t as 2x plus 1 over the square root of 4x squared plus 4x plus 4. And then for cosine t, we want adjacent over hypotenuse, so adjacent is going to be square root of 3 over 4x squared plus 4x plus 4. And so with this value and this value, I think we have what we need to finish this off. So let's just rewrite this. We're going to have, this is going to be 4 square root of 3 over 9. Our t values right here. So we're going to have arctan of 2x plus 1 over square root of 3. Now for sine t cos t, we just need to multiply these two things together. We're going to have square root of 3 times 2x plus 1. We're going to have this square root squared, and what I will do is factor out a 4 now. We're going to have 4 times x squared plus x plus 1. And now to finish this off, I think I'm just going to multiply this in because we're going to get a little bit of cancellation. So for the first term, we're going to have this 4 square root of 3 over 9. And we're going to have our arctan. And then when I multiply this in here times this, the 4's are going to cancel here. The square root of 3 times square root of 3 is going to be a 3 over 9. So this is going to give me a 1/3 out front. And then we're just going to have 2x plus 1 over x squared plus x plus 1. I'm going to add a plus c, and that's it. Okay, pretty good problem with trig substitution, so we'll stop it there. Thanks everyone for watching today. Have a great day.